So, hello everyone. So, this is my third video related to practical. I have given you an introductory video. I am very much encouraged by you people who are watching it. So, please go through it. And this is the second time I am telling these videos are not so entertaining one. Okay, this will solve your purpose. So, this is for class. You can say 9, 10, 11. And in class 12 also we will do the same experiment in a different format. Now it is the experimental verification of Ohm's law, and I have tried my level best in order to make you understand this is the circuit and how we connect the circuit and how we take the reading. And please everyone, see the graph properly, and remember the joining of circuit by viewing the circuit diagram is not so difficult, but what is difficult is to draw the graph. So please go through that portion very properly, and just I am telling you, I want your comments and see the full video properly. It will help you. I am telling you, take my word, it will help you. And few of you have asked me to do this type of videos in Hindi. So I am not at all fluent, so fluent in Hindi, but I will try my level best. So just go through this video properly and let's see whether it is helpful or not. So it's on my behalf. The circuit for experimental verification of Ohm's law is like this. You can see the circuit diagram. There is a eliminator or a DC source and connected with a key, positive end connected with a key to the unknown resistance, the resistance whose resistor whose resistance is to be measured, and here ammeter positive, ammeter negative to the resistance box to the eliminator negative, and a voltmeter is connected in parallel manner. So I have connected the circuit like this. You can see it very properly. See, this is the eliminator. The red one is positive and the black one is the negative. From red one to one, where to the key, see here to here. From key to the unknown resistance, you can see from the key, one wire goes to the unknown resistance. From key to the unknown resistance, this one. So from the another end of the unknown resistance to ammeter positive. So you can see another end of the unknown resistor, this one goes to the ammeter positive, this red one. This negative end of the ammeter negative to the resistance box. You can see that black one wire goes to this, and from resistance box you can see the eliminator positive, that means the black one. So one more thing, keep it in mind that ammeter is always connected in series with the circuit, and voltmeter you can see it is connected with this unknown resistance with parallel manner, as you can see in this diagram. So now remember the procedure is like this. You have to take out 1 ohm resistance from here. You have to I will switch on 1 ohm resistance from the resistance box and take out the ammeter and voltmeter readings, the divisions, and we will multiply those divisions with the voltmeter and ammeter list count. I have shown these how to count the list count and everything in my previous videos, so please watch them. So first of all, again I am repeating, take out 1 ohm resistance, set the eliminator at 3-4 volt mark and take the ammeter and voltmeter reading. Take 2 ohms, take ammeter and voltmeter reading, 3 ohms, 4 and 5 ohms. Repeat the experiment repeatedly, same thing, and take the ammeter and voltmeter reading. And after tabulating the reading, we will do simply like this, R by that is R equals to V by I. We will draw the graph and find the resistance. So this is the circuit diagram, and this is the real circuit for you. Now it's a time to see the list count of the ammeter. You can see it. I am zooming in little bit so that you can see it properly. See, from 0 to 0.25, from 0 to 0.25 ampere there are 10 small divisions, okay, and this ammeter have the range of 1.5 ampere. You can see So it is 1.5 ampere, and between 0 to 0.25 ampere there are 10 small divisions. Here we have seen 10 small divisions. 10 divisions is equals to 0.25 ampere. So in order to find the least count, we should write one division is equals 0.25 divided by 10. So we can write 0.025 ampere. So our least count, of ammeter is coming like this, 0.25 ampere. It is the voltmeter what we will be using for our experiment. You can see the range of the voltmeter is 0 to 3 volt. See, you can see here it is a 3 volt, it is 0 volt. Now let us find the least count. So I am zooming in, you can see it properly. So see, from 0 to 0.5 there are 10 small division. So you can see from 0 to 0.5 there are 10 small divisions. So we will set our least count accordingly. For the least count of the voltmeter, we have seen 10 divisions. 10 divisions is equals to 0.5 volts. So therefore I can write 1 division is equal 0.5 divided by 10. So that gives me 0.05 volts. So therefore I can write least count of voltmeter. Here the thing what we are using is volts. Please check the least count of the instrument given in your board exam. So this is mandatory, so check it. Now I'll switch on the eliminator first and see it's showing. I am showing you say 3 volts or 3.1 volts. It's a time to take out 1 ohm resistance from the resistance box and take the corresponding ammeter and voltmeter reading. So you can see very clearly what is the ammeter reading. I am counting the least count. See 10, 20, 30, 31, 2, 3, 4, 5. So ammeter reading division is 35. Now it's time to take the voltmeter reading. So see here the voltmeter reads, I can tell 10, 20, 30, 32. So 32, or you can take 33 also. So ammeter reading is 35 and voltmeter reading I am taking it as 32. So for the first observation, I have taken out 1 ohm resistance from the resistance box, and ammeter reads 35 divisions and voltmeter reads 32 divisions. So as usual, we will be multiplying this with the least count 0.025, and here also I will multiply this with the least count 0.05. Now for the second reading I'll take out a 2 ohm resistance from the resistance box. You can see I am taking out 2 ohm resistance from the resistance box, and correspondingly I'll take the voltmeter and ammeter reading. So let's see how what is the reading of the ammeter. So very clearly you can see the ammeter reads 10, 20, say 29. Ammeter reads 29 divisions. Now let's see the voltmeter reading. So the voltmeter reads, see it very properly, the voltmeter reads 10, 20, 26, 27. I can take it voltmeter reading at 27. For the second observation, I have taken out 2 ohms resistance. So my ammeter reading is 29, and I'll multiply it with the least count, and the voltmeter reading is 27. So just multiply it with 0.025 and here multiply it with 0.05. Now for the third reading, what I'll do, I'll take out 3 ohm resistance from this resistance box. So I am taking out 1 ohm and 2 ohms. You can see very clearly 1 and 2 ohms from the resistance box. That means this total resistance of this total circuit is 3 ohms now, and we are finding out the resistance of this one. So let's check the ammeter reading. What ammeter is reading is 10, 20. You can take 24 or 25. I'll take 25. Okay, 25, and see what the voltmeter reads. Now see, gradually voltmeter reading is also decreasing. It is coming as 10, 20, 21, 2, and between 2 and 3 you can take any value. So I am taking 22. For the third observation, I have taken 3 ohms resistance from the resistance box and ammeter reads 25. So that gives me 0.025 into 25, and my voltmeter reads 22 into the least count 0.5. So for the fourth reading, I am taking out 4 ohm resistance from the resistance box. So you can see very clearly what are the 2 knobs I am taking out, 2 and 2. Okay, so my eliminator is on. Now same thing I am repeating. Sounds check the ammeter reading. So ammeter reads, you can see it clearly, 10, 20, 21. So the ammeter reading is 21 divisions, and let's check the voltmeter reading once. See, the voltmeter reads 10. I am taking it as 19. So voltmeter reading is 19, and I have taken out 4 ohms resistance from the resistance box. For the fourth observation, I have taken out 4 ohm resistance. It is a very easy experiment. So it is a 21, ammeter reading 0.025 and voltmeter reading is 19. So 19 into 0.05. So for the fifth reading, the same thing I'll do. I'll switch on the eliminator again. Every time after taking the reading, just switch off the eliminator. So I am taking 1, 2 and 2. So that gives me 5 ohms resistance. So let us check the ammeter reading again. So see here what the ammeter reads. Ammeter reads say 10, 12, 14, 16, 17 or 18 you can take. I am taking 18. So ammeter reads 18 divisions, and let's check the voltmeter reading. The voltmeter is reading 10, I can take 12, 13, 14, 15, 16. I can take 16. So voltmeter reading is 16 for 5 ohm resistance. For the fifth and last reading, I have taken out 5 ohm resistance from the resistance box, and my ammeter reading is 18. So 18 into 0.025, and my voltmeter reading is 16 into 0.05. Now a very important thing I'd like to tell you, that see, with the increase in resistance, as we know from the Ohm's law, and we are determining the experimental verification of Ohm's law. So see here, with the increase of resistance, gradually the current, that is ammeter reading, decreases and voltmeter reading also decreases. So this experiment has a decreasing trend. Now I have made the observation table here. I have taken all the readings and I have just multiplied it with a least count. See, my ammeter readings are coming 0.875, 0.725, 0.625 like this, and I'll round it off to make up to 2 decimal point. See here, 0.875, you can take it as 0.88 or 0.87, but I have taken 0.87, the lower value. And see the voltmeter reading 1.60, 1.35 like this, and I have divided voltage with current. That gives me the resistance of different values, and finally these 5 resistance, what I have got, I have taken out the mean of 5 resistances, so all the sum divided by 5, that gives me 1.806 ohms, and I have rounded rounded off as 1.81 ohms. Now it's so my result of resistance of unknown resistance is 1.81 ohms. Now it's a time for the very important thing, that is to draw the graph and see whether it is matching with this one or not. So I have just for the graph I have prepared my table like this. It will show you clearly how it looks like. So see here, all the readings I have tabulated again from this observation table to this observation table. Now see, it's time to draw the graph. For the graph, I have taken the ammeter reading in x-axis. See, this in x-axis I have taken I in ampere, and voltmeter reading I have taken in y-axis, that is V in volts. Now see how I am setting the scale here. See, first of all, I will be setting the ammeter reading. It is starting from 0.45. So if you take 10 division, but it will not be accommodated over here, so I will take that origin as 0. Say I am taking it 0.2. So this will be 0.3. So this will be 0.4. This is 0.5. This is 0.6. This is 0.7. This is 0.8. This is 0.9, and you can take 1.0. You can shift the origin like this. So all the values of this one I can accommodate here. But see, this voltmeter reading, it is starting from 0.80 and ending at 0.16. So I'll shift my origin as 0.7. So y-axis is starting from 0.7. So after 10 division, I am writing 0.8, 0.9. This is called shifting of origin, and in my earlier videos, I have shown you how to change the origin, how to shift the origin, and this is permissible for accommodating a larger value. Don't use the kink, you have to shift the origin like what I have done just now. So this is 1.3. So I have taken 10 division is equals to 0.1, and in scale also I will be putting exactly the same thing. I will show you that 6, and this is I am taking one more extra 1.7. Now see, I have plotted x and y axis. The main important thing what I have done, I have shifted the origin. Okay. Now I have set the scale accordingly. You can see it is the most important thing. I have told you repeatedly to set the scale. See, 10 small division along x-axis. See the x-axis, 10 division equals to how much? 0.1 ampere. And along y-axis, 10 division equals to 0.1 volts. So see the scale what I have written. See, 10 small division along y-axis equal to 0.1, so 1 small division equals to 0.01 ampere. And similarly, along y-axis, 10 small division along y-axis 0.1 volts, so 1 division equal to 0.01 volts. So now it's a time to plot the graph for you. So see it very clearly. I am just adjusting it so that you can able to see it. So first point starts from here. I can start from here. So 0.87, 1.6. So where is 0.87? You can see here clearly 0.8 and 0.9. So this is my 0.87. Just mark a single plot here, and 1.6. Where is 1.6? Go upward. So I'll be having 1.6 here. So this is the point what I have drawn here. See, this is 1.6 and this is 8.7. 0.87. So this is my first point. So I have done this one. Okay, so I have done this one. Next point is 0.72. Where is 0.72 in your graph? This is 0.72 and 1.35. So let's check where is 1.35. Here is 1.3, here is 1.4. So this will be 1.35. So 0.7 to 1.35 will be here. So you can see it clearly. I am plotting it here. See, go downward, it will be 0.72. From here to here, it is 0.35. So my second observation is done. The third one is 0.62. You can see it is 0.62. I am plotting it here. 0.62 is here. And 1.10. Where is 1? You can see here only. So 0.62 and 1.10 is here. Okay, so I have plotted this point also. So the fourth one is 0.52. Where is 0.52? Here is 0.52. And 0.95 is, where is 0.95? Here. So I'll plot the point here. And don't worry if those points don't lie on a straight line. It can vary because you are doing the proper experiment. So last one 0.45. So where is 0.45? This one, and 0.80. So 0.45, 0.80. You can see I have plotted the 5 plots. And now to draw the best fit line, what I'll do, I'll zoom little bit out so that you can able to see all those points here. So here you can see clearly the 5 points. Now it's time to draw the best line of best fit. So you can see clearly all my 5 points lies here. So see, deliberately I have taken these points so that they does not lie on a same straight line. So see here, just it will be a straight line. So I'll draw this line for you. So this is a straight line. You can see few points are above the line, 2 points are below the line. I can do it like this also, so it can be adjusted properly. So I am how I am shifting it. This, see here, these points will be on the line. So I'll put it like this, and these 2 points are above and these 2 points are below the line. So I'll draw the line of best fit like this. See, I have drawn the line of best fit. You can see. So extrapolation is done. So little bit elongation here and there. So I have drawn my best fit line. You can see it properly. This is my best fit line. Now it's a time to draw the slope of the graph. So I'll be taking one plotted point. So I'll choose this point as plotted point, and another point I'll take it from the lower portion of the graph, and I will choose, you can choose any point from your observation, but I'll choose this point. In my opinion, this point is exactly at the point of intersection. So what I'll do, I'll just mark those points on the x-axis and y-axis. So you can see, so this is the points what I have found. You can choose other points also, it depends on you. So you can see it. And for that top point, I'll do it like this. So this is it. So that might vary, and your slope value might vary. There is a almost 10-15 marks deviation is allowed in exam. And remember, when you are doing the proper experiment, your result may vary little bit. So I have drawn the slope. I can draw this triangle also. So it is, what is the this point? This point is, see here, 0.87 and 1.0.87 and 1.6. This is the first point. And what about this point? What is the value of these points? So 0.51, and this is 9. So you can see properly 9.123. So I can take 0.93. So this is my x1, this is my y1, and this is my x2, this is my y2. So for a slope, I have told you, you can calculate the slope here only. You can calculate the slope at this place. So I'll write here only the calculation of slope. See here properly. So slope calculation, S equals to, we all know, y2 minus y1 by x2 minus x1.
So just put those values. Y2 value is 1.6 minus Y1 is 0.93 divided by, I can write X1 value is, X2 value is 0.87 minus this one is 0.51. So I'll calculate it for you. So 1.6 minus 0.93, that gives me 0.67 divided by, you can write 0.87 minus 0.51. So this is 0.36. So what is the value I am having? So 0.67 divided by 0.36, it is coming around 1.86 ohms, remember, ohms. So see, from my graph the result is 1.86 and from my observation table it is coming 0.81. so these two, I can take these two values because this is less than 10% or 15 or 20% deviation. So almost these are matching, so I can take this value. So from observation the value is coming 1.81 ohms, from the graph it is coming 1.86 ohms, so you can take this value. So this is the VI curve for Ohm's law. Now that's the end of that one, experimental verification of Ohm's law. Hope you have understood it. If you have got any doubts, any queries, anything to ask me, you can ask me. All the things are given in the description box, and you can ask me anything related to this topic. So soon I'll give you some more practicals related to this, and again I am telling, I have not provided any PDF or something like that. I want you people to write the observation table and draw the graphs looking into the video. So thank you very much for listening to my words and seeing those things, and please, if it is helpful, to share this as much as you can with your friends, and please do subscribe my channel. It will encourage me, and thank you very much for watching it. Thank you.